Resolve 10 minus 2x divided by x minus 3 times x minus 1 into partial fractions. Now listen, when two or more fractions are added, we get a single or a compound fraction. That compound fraction can be reversed or can be decomposed back to those individual fractions that were added. Now this is an example of a compound fraction, and we will be asked to dissolve or decompose it into partial fractions or individual fractions. Now, for us to achieve this, there are points to note. Number one, the numerator here, the polynomial in the numerator has a degree of 1. That's the power of x is 1, while the denominator here, the power is 2, and it is not repeated. So, for us to separate this, it means that since each factor in the denominator are linear factors, therefore the numerator of each should be a constant. So we can write this as 10 minus 2x equal to, that's over x minus 3, x minus 1. So it's separated, then we have two factors. So the first one, we have x minus 3. Then the second one, we have x minus 1. These are the two factors. Now, since the degree of x here is 1, then the numerator should be a constant. So let's call it a. Similarly, this should be a constant. Let's call it b. So we have separated into two separate fractions. Now, the next thing we do, we are going to clear these denominators. For us to achieve that, we use the common denominators, the common factors here, okay, or the LCD. So multiply through by the lowest common denominator, which is x minus 3 times x minus 1. So when you multiply here by x minus 3, x minus 1, it will cancel this. So we're going to be having 10 minus 2x equal to, so the x minus 3 from here will cancel this, leaving us with a into, we're left with x minus 1 plus b. Then the x minus 1 cancels this, we're going to be having x minus 3. So I haven't done this. The next thing we do is to eliminate a or b to get one of the unknowns. So our goal is to get our constant a and b. There are different approaches that can be used there. One, we can use the cover-up method. We can use the method of equating coefficients, or we can simply eliminate one by substituting a value in either of these to turn one of the constant to 0 while we find the other one. So I can decide to eliminate a. To eliminate a, set x to be 1, such that when I substitute 1 here, I have 0 and a is eliminated, so I can find b. So when x is 1, so we're going to be having 10 minus 2. So here, x, replace x with 1 here, equal to a into x is 1 minus 1 plus b into x is 1 minus 3. So this will give us 10 minus 2 times 1 is 2. Here, this will go to 0 because 1 minus 1 is 0. To take that to 0, equal to b times 1 minus 3 is minus 2. 10 minus 2 is equals to 8, equals to b times minus 2 will give us minus 2b. So if you to get b, divide both sides by minus 2, so that this will cancel out. That implies that our b, 8 divided by minus 2, is equal to minus 4. Now to get a, we have to eliminate b. So to eliminate b, we can set x to be equal to 3, so that 3 minus 3 will give us 0 and b is eliminated. So when x is 3, the left hand side we have 10 minus 2, replace x with 3, equal to a into 3 minus 1 plus b into, now x is 3 minus 3, so that we have 10 minus 2 times 3 is what? 6, equal to, now a into 3 minus 1 is 2, 3 minus 3 is 0, so this goes to 0, leaving us with 10 minus 6 is 4, equal to 2a times 2, that's 2a. To get a, divide both sides by 2, so that this will cancel out. That implies that a, 4 divided by 2, is equal to 2. Now we have our constant terms. A is 2, b is minus 4. Now coming back to the original expression, so we have, now say therefore, our 10 minus 2x all over x minus 3 times x minus 1 is equal to, now in place of a, we'll substitute 2 all over x minus 3. Then this is plus b. Now b is negative, so negative times positive will give us a negative. Then b is 4 all over, then we have x minus 1. And these are the corresponding partial fractions of this compound fraction. Thank you so much for watching this video.